Okay, so we trying to learn how go from a spectral, like a HNMR spectrum like this, and find what the chemical structure is. There are many different ways we can do this, and I liked what Dr. Klein has. So this homework is actually from Dr. Klein. So we have a formula for this compound. C5, it's hard to read it, but I'll just move my paper a little bit here. So it's C5H10O. So the first thing we really need to find what deficiency is. Remember the hydrogen deficiency? So hydrogen deficiency is telling us, do we have a double bond or uh, maybe a ring? So let's measure the hydrogen deficiency. We have 5 carbons times 2 plus 2, remember, minus existing 10 hydrogen divided by 2. So if you do this 12 minus 10, so it's 1. So we have one double bond or a cyclic structure. Now, later on we're going to talk about we have an oxygen. So there is a good chance that the double bond would be C double bond O, a ketone. Or it could be an aldehyde. So let's go on and find out. So we did find the indexes. So the index is 1. So we did this. Then identify the number of different, I'll read it to you. Find the spectra, identify a number of different signals. So remember, if the hydrogens or protons are different, we have different signals. So also let's put letters there. We like the letters, so we can put A, B, C, and a D. Typically we go from right to left, if I remember correctly. So what is A now? So A, basically, as you can see, is a triplet. So A is a triplet. So it's a triplet. We'll show it by T. This B is hard to read it, but the little guys here, there are 6 of them. So this is a sextet. So we call it by X. I should have put an E there. SEX. So put it SEXTET. 6 of them. Then we have a single here. And again, we have another triplet here. So we have basically 1, 2, 3, 4 signal, a triplet, a sextet, and a single, and a triplet. Then we need to look at the area under the signal. So we have that. We have 42, 28.4, and these are actually the computer measures that. And if you remember, we divide that by the lowest number. So the lowest number is actually 27. So the lowest number area count is 27. So we divide it by 27, 27, 27, 0.0, I didn't put the 0 there, 27. So this one is 1, basically, right? Remember, 27 divided by 27 is 1. Then we have, okay, so we have, so of course the lowest number is 27, so it's 1. Then if you divide 40.2 by 27, you get 1.48. Then we get for this one 1.05. For this one we get 1.56. Of course these are not integers, so we have to really convert that to integer. Now if you look at the integer here, it doesn't add up to 10. Remember, we have 10 hydrogen. So the easy thing, some cases like this case, is to multiply everything by 2. So if I do that, and it comes with practice. So this becomes 2. So this D, hydrogen signal D, become 2. The next signal, 1.4, is 1.5. So this could be 3. Sometimes it doesn't add up, but this one it does. Then 1.05, we ignore the 0.5 and it goes 2. And then the last would be 3. So now I can go put the number of hydrogen for each signal underneath of it. So for A, we would have 3 hydrogen. For B, we're going to have 2 hydrogen, or the 3 hydrogen represented by this signal. 2 hydrogen represented by this signal. 3 hydrogen is represented by this signal. And the last but not the least, 2 hydrogen or proton is represented by signal D. So we did that. We did the area count. Look at the area count. We identified the number of hydrogen for each signal. Now the next step is to look at the ppm. Look at the ppm. Look at the number of hydrogen. Look at the splitting pattern. For like the first one is a triplet, right? So if you look at A, which is a triplet, so let's look at the A as a triplet. So if I look at the signal A as a triplet, and we know there are 3 hydrogen there, right? So there are 3 hydrogen, and those 3 hydrogen become a triplet. So what does it really mean? So if I have a 3 hydrogen here, and these 3 hydrogen around 0.9 ppm became a triplet. So that's the part that we need to look at what's the next to it. I can't have anything on this side. So on the left side, so let's use a green color. So I have on the left side, or if I would have drawn the other, so I have 2 hydrogen. I don't know what this is attached to, but I know that 3 hydrogen, the 3 hydrogen is attached to a 2 hydrogen. So if that's the case, then it becomes a triplet. Now the color didn't change much, but next time I'll use a red or purple or something. So this is A. So let's look at B. So B is 6 or sextate. So there are 2 hydrogen that became 6. So it's a 2 hydrogen. So let's draw the 2 hydrogen. For this 2 hydrogen to become 6, so we need a 3 and a 2. 3 and a 2. 5 plus 1 is 6. So we can draw a CH3 on the left side. So we can draw a CH3 on this side and a CH2 on this side. I know it's getting busy, but we really need to put this together. So we talk about A, we talk about B, A and a B. So the B, these 2 hydrogen, which we calculate, sees 5 hydrogen next to it, so become a sextet. Sextet. So let's look at the C now. So C, oh, look at the C. C is only singlet. So that means C doesn't have anything as a hydrogen goes next to it. See, C doesn't have anything, and there are 3 hydrogen there on C, right? We look at the ppm. So the ppm is 2.19, 2.18, close to 2.2. Remember, CH3 by itself is 0.9. Now it's downfield, added ppm to it. So most likely, this is the one next to the C double bond O. So if I put a C double bond O here, so if I put a C double bond O for C, look at that now. It's a single. It doesn't have any proton next to it to split it. So that, so far so good. We have some idea for A, idea for B, an idea for C. Let's look at the last one, which we call it a D. A, B, C, and a D. So D basically is a triplet, right? D is a triplet. So it would be, and there are 2 hydrogen underneath. Remember, we measured that, 2 hydrogen. So there are 2 hydrogen for D, and they are triplet. So that means it has only a CH2 next to it. So there are only 2 hydrogen next to it. So put the hydrogen here, or proton here. I call it hydrogen, but you should really call it proton. So this is my D. So we did now have an idea, but A, B, C, and a D. So we have an idea. Now we have to put them together. Again, it takes time, it takes practice, and we just try it. And if it doesn't work, we go back and look at it again. So let's start with the carbonyl group. So we put the carbonyl group here. So let's put the carbonyl group here. So we know the carbonyl group on the left side, or the right side, doesn't matter where we put it, has a methyl group, which is the C. Remember the C? So I put a methyl group here, and these 3 protons are going to be the C. Then we have on the right side, we have many CH2. So let's put one of the CH2 here. So this CH2 is next to the C double bond O. Remember, CH2 is 1.7 typically. So it's 1.7. We look at D. Look at the D. If you look at the D, the ppm is 2.4. So that's the one next to the C double bond O. We added 1 ppm to it. So this would be my D. So this would be my D. Then let's look at obviously this has to have a CH2 next to it. I put a CH2 next to it. So it's a little bit away from the C double bond O. So it's not 1.7, maybe a little bit higher. Maybe a little bit higher. So we're looking at the B. Remember the B? So the B actually has a 6 it. So it's a 6 signal. So that's match now, because if I put B here for these 2 protons, I can put next to it the other methyl group. So if I put a methyl group here, so that's the methyl group that became a triplet, which is A. So this is my A. So this jigsaw puzzle is solved. So we have A, B, C, and a D. And remember, this A, B, C, and a D came from the spectrum, not from the structure. Not from the structure. So we double check ourselves, always double check ourselves. We look at the A, next to 2 protons. So this would be a triplet. Look at the B, has 5. So it would be 6 of them. 1, 2, 3, 4, 5, 6. D, next to 2 is a triplet. Next to the C double bond O. Obviously C double bond O doesn't have anything. And CH3 here is a singlet. So we have a singlet, a triplet, and a sextet. And that's the same as structure. So now the next exercise that we're going to propose to do is going from a structure to drawing an NMR for it. Okay, so we stop here. The next exercise would be going backward. We start with the structure and see if we can draw this spectrum from it.